Hello everyone, we are going to be doing Unit 7, Lesson 4 today. If you haven't already, get your binder out, go to Lesson 4, and when you've done that, if you need to hit pause, as usual, hit pause anytime if you need to slow down. But if you're ready to rock, then let's do it. Warm-up problem, true or false link relationships. First off, it says let's figure out some missing angles. So we've talked about vertical angles, or I often call them opposite angles because they're kind of opposite away from one another. Learned that they're equal. We've also learned about complementary angles. Complementary, they give compliments to one another, like, hey, I really like your tie. And then we have supplementary. Supplements are something you take when you're lifting weights to get big. So supplementary angles are 180 degrees. Complementary is 90. If you smiled at anything I just said, you lose. So with all that in mind, we're going to make some equations that are going to be somewhat pretty straightforward if you've followed along with lesson 2 and 3. So first off, the warm-up says, here are some line segments. Decide if each of these equations is true or false. Be prepared to explain your reasoning. CD, that's from here to here, that distance, plus BC, that distance. So BC and CD is equal to BD. Is that true? Hopefully you say, yes, that is true. Be prepared to explain your reasoning. What could we say? Sounds too obvious, but sometimes explaining the obvious is good training for explaining the not so obvious. But we could say the distance of BC plus CD equals the same distance as BD, something along those lines. Let's see, AB and BD. AB is from here to here, plus BD. So pretty much just the whole line that's there. Is that equal to, why do we don't need to erase, let's just switch colors. CD, by switching colors, I meant switch colors. CD plus 80, that plus 80. That seems like it's going to be a slightly bit more. It's going to be longer. We should say false because all of it plus a little bit more is not going to be equal to all of it. Ooh, this one looks tricky. A little bit of subtraction. AC, that's that distance, minus AB. If I get rid of, what part of me tapping on red don't you understand? Minus AB, well, that leaves me with BC. Is that equal to AB? No, that should be BC is what it should leave me with. So you are false. And everything I just said is my reason. And what do you guys think about the last one? Go ahead and try BD minus CD. Is that going to be equal AC minus AB? True or false? I'll give you a clue. It's either one of those. It's true or false. BD, BD, there's that, minus CD, minus that. If we get rid of that, we're left with BC. So this side is equal to BC. and that you get AC minus AB, go ahead and give that a try. You will notice that it is also equal to BC. So guess what? We should say it's true. All right. That is a warm-up because, believe it or not, that was just line segments, but everything we're doing is very relevant for finding angles and missing angles. So this first activity is an infogapping. So you're supposed to have one card and your partner is supposed to have the other, and if all things play out well, you will do this activity, but I'm going to go ahead and do this one in case all doesn't go well and we need to just do this on our own. And it's actually not a bad idea because quite literally, if I'm giving you what I have right now, you're not given the answer. So let's go ahead and figure it out. Let's do it. Problem 1, find the measure of angle B. That means we want from here to here, we want angle B. So if we were actually doing this in real life, we would ask our partner whatever questions we want. We're only able to see this, and we would say, hey, we would think we're funny, and we would say, what's the measure of angle B? You know, but obviously our partner doesn't have that. But we could say, do you know angle A? And they would look and say, no. You would say, do you know angle E? And they'd look and say, no. Do you know angle D? Well, yes, I do know that. Angle D is 124 degrees. So we'd, okay, let's write 124 down on our card. Angle C, yes, we do know that. That's 56 degrees. And that makes sense. Our partner didn't really need to tell us that. Why? Because we have a straight line right here. For crying out loud, this is not good. Hold on one, folks, you guys. I would pause this, but it's not allowing me to do that. Hold on one second. Hold on. Buddy, I'm recording a video right now. I can't pause it. What's wrong? What's wrong?
I need some water.
You need some water?
Yeah.
Yeah. You're all better? Okay, lay back down. I love you.
Bye, better get some sleep.
Mm-hmm.
When I'm gonna be done doing that?
In a few minutes. Go to sleep, okay? I love you.
And I don't turn up. I want to put that in around this one. Or this pillow is. No.
You want to switch them?
Yeah. Let's switch them.
Okay.
No, I want that one on the walker, I said.
Oh, okay. Like that?
That one. Yeah.
Okay. All right, get some sleep. I love you. Okay. Sorry about that. I thought he was asleep and he needed some water. Fancy that. Anyway, where were we? We knew that those two added together, that one plus that one, 124 plus 56, we should see, hey, that's a straight line. And we learned yesterday, hey, that's a complementary angle. Those are adjacent angles that are complementary. Supplementary. And they add up to 180. 124 plus 56 does equal 180. So, with that being said, what else do we need to know to figure out angle B? Well, we can notice that this angle, let's go with this, is vertical angle. If this is 56, then it means this is 56, which is good to know. That might be useful. It says C and E are vertical angles, so guess what? We just did that. It says A and C are complementary. A and C are complementary. Which one is C? Where is C? There's C, that one. So, gosh darn it. Oh well. If they're complementary, it means A, let's use a different color. A plus C equals 90. Well, we don't know what A is, but we know C is 56 equals 90. So something plus 56 equals 90. So if we subtract 56, we get 34, I believe. So we just found out A is 34. So how are we going to figure out what B is? Lots of different ways. Sorry, I was trying to write a by. That was supposed to be 56. Well, guess what? I see the same straight line right here. I do know that this angle plus this angle plus this angle make a straight line. And I see 56 plus 34 plus something, whatever B is. Actually, I shouldn't use a question mark. Let's call it B. I know that's all going to equal a straight line, which is 180 degrees. So 56 plus that 34, well, guess what? That's a 90. Less B equals 180, which must mean if we subtract 90 from each side of the equal sign, B must be 90 degrees. A lot going on there, but very doable. You just got to plug in all the numbers, and then you got to recognize straight lines and opposite angles or vertical angles, and complementary means add up to 90. Very doable. So let's look at this last one. Problem card dos. Find the measure of angle B. The measure, let's go ahead and look at this. This is what we want right here. That blue one. Got a lot going on here. We're going to learn about transversals in a little bit, but and parallel lines and all that. But for right now, we just need to go, okay, if we're asking our partner, hey, do you know what angle A is? And let's see, they'll say A is 90. Great, let's write it in. There is, what part of me tapping on this? I have to do it 100 times. So A is 90. That's fair enough. Again, you tell us what C is? Angle C, no. But they say C and Z are vertical, meaning this and this are equal. Vertical angles mean they're the same angle. So we could ask our partner, hey, do you know what angle Z is? And Z is 63 degrees. So if this is 63, then guess what? This is 63. And we've got enough information now to figure out the rest, because if you look right here, I've got a straight line. And I know that 90 plus something equals 180. Well, I shouldn't say something, that's 63. So 90 plus B plus 63 equals 180. So what do we do now? I'll let you figure out the rest. Hopefully you noticed that we should add 90 and 163 first, and notice that's 153 plus whatever that angle B is. And next we subtract 153, and B would equal 27, I believe, not 37, 27. So some great problems. Notice I am using, see that? That's an equation. I'm a math teacher and I have to write equations. Otherwise, that's an equation right there. Well, technically the one is above it as well, but they help me think through problems and when I need to add and when I need to subtract. Who did say angle D and X are supplementary? I wonder if I needed to know that. D and X. Didn't need to know that, but that just means those two, if you add them together, they equal 180. D and X. I guess what they're trying to say is, if I knew this is, whoa, come back here. If this is 63 down here, then that means this is also 63 since it's a vertical angle, since they cross like that. And then 63 plus D, that equals the 180. So this is another way we could have found it. 180 minus 63 would have been, well, what is 180 minus 63? 117. So that means D is 117. And I hate to erase all this, but if I notice, so if this is 117, then that means from here to here is also 117. Because they are, that would be a vertical angle, and that means this 90-degree angle, if I got rid of it, oops, sorry, I should have gone all the way to there. All of that is 117. 117 minus that 90, well, guess what? We still get 27. So there's lots of ways to solve that, actually. I didn't look at that last guess. I guess what will we ask? So I guess if we're being the partner, we would ask, hey, are there vertical angles? Are they supplementary? Are they complementary? Just keep asking questions until our partner gives us something. All right, now let's go back to .3. It says, what's the match? Match each figure to an equation that represents what is seen in the figure. For each match, explain how you know they are a match. I'm going to read that one more time. Match each figure to an equation, okay, that represents what's seen in the figure. For each match, explain how you know they're a match. So for A, I'm looking at that. The only thing I can see is those are vertical angles. There's no other information. I know that G and H are what we call vertical, or opposite angles, but vertical in this case. So let's go ahead and say, well, I just know that these are equal. Is there an equation that says G equals H? Guess what? We'll write a number 2 next to that. Let's use something. So that's number 2. I don't want to cross it off because maybe we're going to use it again, but B, I see those are what you call supplementary angles. They form a straight line. This one plus this one make a straight line. That plus that. That means a straight line is 180 degrees. So G plus H equals 180. So that goes with number 1. Again, I'm not going to cross them off because maybe we're going to use more than one once. And let's do letter C. Oh boy, we got all sorts of stuff going on. I see 35. If that's 35, then this is 35. And I do notice that then I'd have a straight line, which means H plus 35 plus G makes a straight line. That means, let's see if G plus 35 plus H equals 180. Straight line is 180, and G plus H plus 35, that goes with number 5. Letter D. all sorts of crazy stuff. I do see a 90 degree. If I zoom in right there, that little square means I got a 90-degree angle right here. I got H. Is that an H? Very blurry H. I got H plus H. And if this is G, then the opposite angle is also G. I've got H plus G equals 90. I do not see H plus G equals 90, but I do see two H's and a G, which is the same thing as H plus H. So for D, we should be putting 3. And then finally, I see a big straight line. I see a 48 plus G plus H. I see this plus this plus this equals 180. A straight line is 180. And that must mean G plus H plus 48. That goes with number quattro. So, long story short, and whether you need to write this in your To My Future Forgetful Self or not, I'll leave that up to you. But everything we've been doing, we can put equations to this. We can put unknown variables into all this, such as x plus 42 equals 180, such as 28 equals y, such as if these are complementary, if these make complementary, that means they make a perfect square. That means 64 plus z will equal 90-degree angle. So let's practice this. Lesson 4, practice problems, solving for unknown. Number 1, M is a point on a line segment, KL. Line segment KL is just saying KL, that's a line segment. M is a point on line. There's M, that point is on that line. Okay, thank you for all that. NM is a line segment. I see that. That's that line, NM. Select all the equations that represent the relationship between the measure of the angles in the figure. Well, KML makes a straight line, so I am seeing an A plus a B equaling 180. So that is definitely D. A plus B, is that it? A plus B. This kind of goes back to our warm-up problem. This is saying, is B minus A? Let's look at this one. Is B minus A this minus this equal to 180? No. Is A equal to B? No, not enough information to know that. Is A plus B equal to 90? No, it's equal to 180. C, and there's nothing that suggests 90, so it's not C, but what about E? 180, if I took the whole 180 degrees, if I took the whole 180, and I got rid of this angle, if I got rid of that, what would I be left with? In other words, I did 180 minus A. Am I left with B? Yes, I am. So our answers are D and E. D and E. What does this spell? D. Number 2. Which equation represents the relationship between the angles in the figure? Well, now this is saying, hey, something plus 88 plus something, but that B has to be the same thing. So I do know, again, I see a straight line right there. So I know that B plus 88 plus B, or that's 2 B's. I know that's all going to equal 180. Not going to equal 90, so we're not going to say C. I'm not going to say A, because we're not talking 90s. Maybe it could be 90 for all I know once I do some figuring out, because technically we have enough information to find out what B is, believe it or not, since B is the exact same thing. But it's either 88 plus B? That's not right. It's not B, because it's 88 plus 2 B's. is equal to 180. So that was easy. That wasn't even multiple. We only had to select one. Come on now, challenge me. Number 3, segments A, B, segment EF. This is weird because there's no dots. So it's saying this line, and CD all intersect at point C. Okay, duh. So they all attach right there. And angle ACD is a right angle. So that tiny little square and this angle right here, that's a right angle. That means it's 90. Find the value of G. Well, hopefully you're looking closely and you're noticing from here all the way to here is 180, which means from, let's call this blue, that's 90 plus the 53 plus G. We don't know what it is, but we know it's all going to equal 180 degrees. So the 90 plus the 53, well, that's going to be 143 plus whatever G is. That's going to be 180. So what should we do now? Something plus G equals 180. Or sorry, not something. 143 plus G. So if I get rid of that 143, that is some sloppy writing. 143. If I get rid of that from each side of the equal sign, notice I always want it to balance. I'm left with G equals, it's going to be a 7. I got to borrow. It's going to be 37. Find the value of G. We did. What else we got? We got some more problems. More money, more problems. Number 4, select all the expressions that are the result of decreasing x by 80 degrees. Man, I love these types of problems. Select all the expressions that are the result of decreasing x by 80. So we got x. Decreasing x by 80%. We're going to take it. We're going to decrease x by 80%, meaning 80% of x. So x minus 80%. X, by the way, 80% as a decimal is 0.80 or 0.8 x. And if I had x in my hand and I got rid of 0.8 of it, that's going to leave 0.2x or 0.20x, if you will. And 0.80, by the way, that's the tenths hundredths, that's 80 hundredths. So I could replace that with, x with 0.80 with 80 hundredths x, or 0.20x is also known as 20 hundredths. Tenths hundredths, that's 20 hundredths or 2 tenths x. So let's see here. 20 hundredths x, yes, because that's what I wrote right down there. Decreasing, select all the expressions that are a result of decreasing x by 80%. If I decrease x, if I take 80% away from it, that leaves 20% left. 20% means per 100, 20 per 100. X minus 80 hundredths x, well, that's what I wrote right down there. I got x and I'm getting rid of 80%. 10 minus 20 is 80. 80 100ths is 80%. 80% of x sounds kind of right, but we're getting rid of 80%. We don't want 80% of x. We're decreasing x by 80%. So it's not C, and it's not D, since we already know it's 20%. But if we did this, 1 minus 0.8, by the way, that's 0.2. 0.2 times x is 0.2x. So guess what? A, B, and E are all correct. Number 5, Andre is solving the equation 4 parentheses x plus 3 halves equals 7. He says I can subtract 3 halves from each side to get 4x equals 11 halves. And then divide by 4 to get 11 eighths. Karen says, I think you made a mistake. How can Karen know for sure that Andre's solution is incorrect? 2 ways. One, you can plug his answer, 11 eighths. 11 eighths, if I plug it in right here, if he got 11 eighths for x, well, let's try plugging in 11 eighths plus 3 halves. 3 halves, if I converted that to eighths, I got to times it by 4. So I times that by 4, and that'd be 12 eighths. 11 eighths plus 12 eighths would be 23 eighths. 23 eighths times 4. It's going to be 92 eighths, and guess what? That's not equal to 7. 92 divided by 8 does not equal 7. It needs to equal 7. So that's one long way of doing it, although that's always the number one way of finding out, hey, is my answer correct? Well, plug it in and see if it works. If it works, then yes. You never even have to ask. So that's one way that you could show. It's a great way. The other way is to notice Andre said, step 1, let's get rid of 3 halves from each side. So we decided to take 7 minus 3 halves from each side. That's wrong. Andre, you are working hard, and that's all that matters. But, Andre, I'm sorry, we have learned that we can't get rid of 3 halves, because we don't have 3 halves. We actually have x plus 3 halves, and we have 4 of them. We have 4 x's, and we have 4 3 halves. So it says, describe Andre's error and explain how to correct his work. Well, he doesn't need to get rid of 3 halves. He needs to get rid of 4 3 halves. 4 times 3 halves, which is 12 halves, which is 6. Then he can get rid of 6 if he'd like. 7 minus 6 would be 1. And then he can divide by 4. And 1 divided by 4 is 1/4. And we just found the answer. So I went awfully fast there. But 4 times x plus 3 halves equals 7. 4 times x would be 4x. 4 times 3 halves, well, I just did it. It's equal to 6, or 12 halves. And that's equal to 7. Then I need to subtract 6 from each side. Those cancel, and I'm left with 4x equals 1. 4 times what is 1? Well, the way that we get this is we divide each side by 4, and I get x equals 1/4. All right, I've got to make some space. You might need to rewind and hit pause to see what we got going on here. And it says solve each equation. I'll tell you what, let's just do a couple of these. We are running out of time. Yeah, we are running out of time. But that's all right, actually. You could probably, I'll do some of these. You could finish these for homework. But let's do this first one. There's not even enough space. I don't like how it does this, but so be it. 1/7 x plus 3/4 equals 9/8. Step 1. This is one there are no parentheses. So we actually can subtract 3/4 from each side. And this is been a while since we've had to do fractions, add or subtract fractions. We need common denominators. So 3/4 minus 3/4, those cancel each other. They're gone. Remember, if this was a balanced hanger, if we got things balanced, I can take, as long as it balances, I can take one side off of the other. So I got 9/8 minus 3/4. Well, I have to come up with a common denominator. I got to come up with the lowest common multiple of 8 and 4. And I would say, well, 8 actually is 9/8 is going to stay 9/8. Minus, if I turn this into 8, well, I got to times it by 2. And I got to times the top by 2. If I times it by 2 over 2, 2 over 2, by the way, is 1. 3/4 times 1, still 3/4. Just doubling it. So 3 times 2 is 6. So 6/8 and 3/4 are equal. Now I can do 9/8 minus 6/8. I have common denominator, and I'm left with, I'll make sure I show all my work. So now I can do 9 minus 6 all over 8. And that's going to be equal to 3/8. So now I got to write this over here, underneath here. I did that and got 3/8. And I still have 1/7 x equals 3/8. So what do we do here? Two ways to just explain this. One, I got to divide each side by 1/7. If I divide this side by 1/7, I got to divide this side by 1/7. Why? Because 1/7 divided by 1/7 is 1, and 1x is what I want. And 3/8 divided by 1/7 will give me my answer. That's fine. I can also just skip to the keep, change, flip. Dividing by 1/7, remember, dividing by 1/7 is the same thing as keep, change, flip. If I did that from the very beginning, not that I have to, but I could have, if I times this side by 7 over 1, and times this side by 7 over 1, guess what? I kind of just went ahead and did keep, change, flip. I divided by 1/7. Dividing by 1/7 is the same thing as timesing by 7. And guess what? If I did this, 7 times 1 is 7. 1 times 7 is 7. I'm left with 7/7. Anything divided by itself is 1. And I'm back to everything cancels and just gives me 1x, which is what I want. On this side, I'm left with 3/8 times 7. This is 3 times 7 over 8 times 1. When multiplying, we don't need common denominators or anything. We just multiply straight across. And I'm left with 21 over 8. So a lot going on there. See if you can mimic that. I won't let you do all of them, but see if you can mimic that. I want you to do B. Same problem, slightly different numbers, and they just switch the x to here. So same steps. See if you can switch that. And then don't worry about doing C and D. But let's do E real fast. I've got 8.78 plus 0.02x is all equal 11.3. Step 1 would be subtract 8.78 from each side. 8.78 minus 8.78 is nothing. 11.03 minus 8.78. I wish I had a calculator, but I don't. So I got to borrow here. Can't borrow. Go to there. Make that a 0. And let me scroll down so that doesn't. That's going to be a 10 now. I can borrow, and that's a 9. That's a 13 minus 8 is 5. 9 minus 7 is 2. Bring down the decimal. Gonna have to borrow. That's gonna be, I believe it's 2.25. That'd be a 3. That'd be a 0. 2.25. Let's cross my fingers. And that's going to be equal to what I have left over, 0.02x. Next step would be divide each side by 0.02. Divide this side by 0.02. And I don't have a calculator, so I'll let you finish that. But that's going to be divided by 2, that'd be 1 divided by 0.2. That'd be roughly 10.02. Is going to be somewhere around 100, I think. How many, kind of like saying how many 2 senses are there in $2.25? Yeah, somewhere around there, 100 and something. So, anyway, I'll leave the rest up to you. X equals somewhere around there. And then finally, a train travels at a constant speed for a long distance. Write 2 constants of proportionality for the relationship between the distance traveled and elapsed time. Explain what each of them means. Okay, so yours, I put your table up above mine. I had to scroll down for. But good problem. Explain what each of them means. First off, distance divided by time. Speed is distance divided by time. If I did any of these, this divided by this, or this divided by this, or this divided by this, I think 4 going 180 divided by 4 goes in. Bring down the 0. 45. I should have been able to do that in my head because that makes sense. 180 divided by 2 is 90, so 180 divided by 4 would be 45. So this train is going 45 miles per hour. That's one constant of proportionality. It says, explain what it means. This train, it goes 45 miles in 1 hour. That's what the constant of proportionality means. 45 miles. Now, the second one is, switch it upside down. This one goes in 1 hour. Am I saying that right? If it's 45, then the other one is 1/45. 45 miles, 1 hour goes 45. No, I think I've got that backwards. Because the constants of proportionality are just reciprocals of 1 over 45. In other words, I think it goes, maybe I was right, it goes 1/45th, or sorry, in 1/45th of an hour per mile. I think that's what, I know that the 2 constants are 45 and 1 over 45. The first one is, that's easy. It goes 45. What does 45 mean? It means it goes 45 miles in 1 hour. The second one says it goes 1/45th. In 1/45th of an hour, it goes 1 mile. In 1/45th of an hour, it goes 1 mile. So it's kind of weird. It's kind of saying 1/45th hour per 1 mile. Lots of weird ways to look at that. We're out of time. I kept you guys. I think the bell's probably already ringing. Maybe you aren't even going to hear this, but that's about all she wrote. That's all we're going to do for today. Keep up the good work. I'll see you on the flip side. Peace.